In this video, we are going to talk about how to draw the Lewis structure of carbon dioxide. At first, we have to find out the valence electron for carbon dioxide. So, carbon is an element of group 4a, that is why it has 4 valence electron, and oxygen is an element of group 6a, that is why it has 6 valence electron. But here we have 2 oxygen atoms, so you have to multiply by 2, that is totally you have 16 valence electron, right? So look, there are many ways to draw CO2 Lewis structure, but here I am going to give you the best way to draw the Lewis structure of CO2. Look, carbon here has 4 valence electron and oxygen has 6 valence electron, right? So to fulfill the octet, the oxygen will share 2 electrons and carbon will share 4 electrons. Oxygen will share 2 electron means oxygen will form 2 bonds and carbon will form 4 bonds. So let us show these things. So now oxygen will have 8 and carbon will have 8, that is they will satisfy their octet. So this is carbon, this is oxygen, oxygen. So every oxygen will form 2 bond, right? 2 bond, and carbon will form 4 bonds. So already carbon 1, 2, 3, 4, oxygen 2 bond, 2 bonds. So now look, here we have oxygen has here 4 valence electrons. So oxygen needs more 4 to satisfy its octet, right? So look, now we have used 2, 4, 6, 8, 10, 12, 14, 16. So already we have used all the valence electron, right? So let us delete this. So this is the Lewis structure of CO2 molecule. So now we'll talk about the hybridization of carbon. So can you tell me what is the hybridization of carbon in this Lewis structure? So the hybridization of this carbon is sp. Can you tell me what is the hybridization of this oxygen? sp2, and this oxygen also sp2. Let me explain the hybridization of CO2. Look, in case of finding out hybridization, we don't think about pi bond. We just think sigma bond and lone pair. So look, this carbon has 1 pi bond and 1 sigma bond, right? So look, so we will not think about sigma bond. That is, this carbon has 1 electron region and here 1 electron region, 2 electron region. That is, its steric number is 2. That is why its hybridization is sp. There is no lone pair, but for this oxygen it has 1 electron region, then 2, then 3. Here the oxygen steric number is 3. That is why its hybridization is sp2. Remember, lone pair always goes p orbital. This lone pair will go 1 p orbital, 1 p orbital, like this. So you will have sp2. This oxygen also has steric number 3. That is why its hybridization is sp2. So now we'll talk about the geometry of carbon dioxide molecule. What is the shape of this molecule? According to VSEPR theory, valence shell electron pair repulsion theory, the shape of this molecule is linear, right? linear. So it is not a bend shape. Carbon dioxide doesn't have any bend shape. It has a linear shape with due to no presence of lone pair in the central atom carbon. So the bond angle between oxygen, carbon and oxygen is 180 degree. Look, this is a linear, so bond angle will be 180 degree. So bond angle 180 degree, right? So that's all about the CO2 Lewis structure, the hybridization of CO2 and the shape of CO2. And can you tell me, is CO2 polar or non-polar? Actually, overall CO2 molecule is non-polar, because look, these the dipole moment of this bond and this bond cancel each other due to the linear shape of carbon dioxide. That is why this is non-polar, right? Okay, now let me talk about the formal charge of oxygen and carbon. Here, a neutral oxygen has 6 valence electron, but here we have 2, 4, and we have to consider for half, right, for bonding electrons. So 2, 4, and we will consider half electron, that is 2. 2, 4, 6. 6 minus 6, that is 0. So formal charge of this oxygen is 0. In neutral atom, carbon has 4 valence electron, but here we have 2 to 4. 4 minus 4, 0, right? That is 0 formal charge of carbon, and this oxygen also has 0 formal charge.